Hello everyone, welcome back to my YouTube channel. Myself, I am Pratibha. I am pursuing my Bachelor of Engineering in Electronics and Communication Department at Sri Venkateshwara College of Engineering. In today's session, I am going to discuss about transducers and its types. Before going to the topic, I would like everyone to subscribe my channel. Firstly, let us go through the content. First, let us know what is the actual meaning of transducer, classification of transducer, resistive transducer, working of resistive transducer, applications of resistive transducer, inductive transducer, applications of inductive transducer, and let us see the meaning of linear variable differential transducer, which is commonly called as LVDT, and applications of LVDT. First, let us see what is the definition of transducer. An electrical transducer may be defined as a device that monitors a quantity and converts it into an electrical signal to measurement or possibly for controlling an industrial operation. So, transducers may be classified according to the quantity monitored, like force, pressure, displacement, humidity, liquid level, light level, and velocity, etc. Temperature method of operation is the another way in which the transducers may be classified. The classified transducers are resistive transducer, inductive transducer, capacitive transducer, and thermal transducer, etc. Here there is the classification of transducers based on active and passive, analog, digital, primary, secondary. Based on transduction, the transducers are classified into three types. They are resistive transducer, capacitive transducer, and inductive transducer. Let us see in brief. First, let us know the definition of resistive transducer. The resistive transducers are also known as resistive sensors or variable resistance transducers. These transducers are most frequently used for calculating different physical quantities like pressure, vibration, temperature, force, and displacement. These transducers work in both primary as well as secondary, but generally these are used as secondary because the primary transducer's output can work as an input to the resistive transducer. The output which is attained from it is adjusted against the amount of input and it provides the input value directly. This article discusses an overview of this transducer. Here we can see the simple diagram, a schematic diagram of the resistive transducer, which contains full output slider position, slider, and also zero output slider position. Let us see the working of resistive transducer. A resistive transducer is mainly used in the calculation of temperature, displacement, pressure, and also for the calculation of force. The working of a transducer can be explained by considering a conductor rod as the transducer. The transducer works on the principle of the length of the length of the conductor, which is directly proportional to its resistance and it is inversely proportional to its cross-sectional area. Here, if we consider the length of the conductor as capital L, the cross-sectional area as capital A, and the resistance as capital R and the resistivity as rho, then the resistance can be denoted as R equals to rho L by A. Let us see the application of resistive transducers. A resistive transducer is mainly used to measure the temperature in various kinds of applications. When there is a change in temperature, the temperature coefficient of the resistive transducer changes, which can be used to determine the change in temperature. The resistive transducer can function as a potentiometer, whereas the resistance of the transducer can be varied by changing the length of the resistive transducer which can function as also a potentiometer, where the resistance of the transducer can be varied by changing the length of the conductor. The resistive transducer can be used in the calculation of the displacement. When we apply strain on the resistor, the resistance changes. This characteristic can be used in the measurement of displacement, force, and also in the measurement of pressure. Second one, inductive transducer. A inductive transducer that works on the principle of electromagnetic induction, or it works on the principle of transduction mechanism, is called as inductive transducer. A self-inductance or mutual inductance is varied to measure the required physical quantities like displacement, which is commonly called as rotary or linear, force, pressure, velocity, torque, acceleration, etc. These physical quantities are noted as measures and measurements, linear variable differential transducer, which is commonly called as LVDT. It is the example of an inductive transducer. Using LVDT, linear variable differential transducer, displacement is measured in terms of the voltage induced in the winding by moving the core in one direction. Here the schematic representation of inductive transducer. Let us see the applications of inductive transducer. Inductive transducers are used in proximity sensors, which are used to measure the position, dynamic motion, touchpads, etc. Detection of metals and missing parts, counting the number of objects. The inductive transducers are used in accelerometers, linear and rotary motor galvanometers, LVDT and RVDT, pressure and airflow sensor, electroactive polymers, potential meters, micro electromechanical system, power generations, etc. The inductive transducers are used in the sequential counters, PB monitors and hot monitors, etc. Let us see the meaning of linear variable differential transducer. An LVDT, which is commonly called as linear variable differential transducer, is an electrochemical sensor which is used to convert the mechanical motion or vibration, specifically rectilinear motion, into a variable electrical current or voltage or electric signals, and the reverse. Actuating mechanisms used primarily for automatic control systems or as mechanical motion sensors in measurement technologies. A linear transducer provides voltage output quantity related to the parameters being measured, for example, force, for simple signal conditioning. LVDT sensors devices are sensitive to electromagnetic interference. Reduction of electrical resistance can be improved with shorter connection cables to eliminate significant errors. A linear displacement transducer requires 3 to 4 connection wires for power supply and output signal delivery. Here we can see the schematic representation of the linear variable differential transducers. Let us see the applications of LVDT. Linear variable differential transducers have been widely used in applications such as power turbines, hydraulics, automation, aircraft, satellites, nuclear reactors, and in also many other sectors. These transducers have low hysteresis and excellent repeatability. They are also used in wide array of industries such as aerospace, defense, robotic, automation industries, medical industries, and much more. Then this work in the same manner as most of the other sensors. Thank you.